Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Your host is Tobias Macey, and today I'm interviewing Satish Jayanthi about the practice and promise of building a column-aware data architecture through intentional modeling. So, Satish, for folks who haven't listened to your previous appearance on the show, if you can just start by introducing yourself.
Yes, thanks, Tobias, for having me. My name is Satish Jayanthi. I am a co-founder and CTO at Coalesce.
And do you remember how you first got started working in data?
Oh, yeah, absolutely. So I started my career, in software engineering, application development, and I was dabbled in that for a few years and was working for a startup in year 2000 in Los Angeles. And this we were selling online courses for large financial firms. There was a lot of boom at that time, as you know. You may have heard how the online internet was taking off and everything was very, very getting very hot. So at that time I was working there, and a lot of times what happened was people would come to me and say, hey, can you give me this report? uh, you know can I have that report? Can I have this report? And I started kind of taking those requests as they came in and started building stuff and giving them. But at some point, I realized that this was just overwhelming. It was just not, I was not able to keep up. And that's when I started looking more and more into how this is done usually. And, that's where I kind of hit the topic of data warehousing, how to build it right, how the dimensional modeling and all of that. So I started like that, accidentally getting into it, and never looked back.
And so, in terms of the overall space of data warehousing, data platforms, obviously the cloud has been the most impactful change in the ecosystem for probably the last decade, if not longer. And in the process of moving some of those data warehousing and data platform workloads, large organizations in particular have taken a bit of a longer time to do that because they have more existing infrastructure. They have bigger risk involved in actually making that migration. There are more moving pieces to coordinate around that. And so a lot of the patterns and practices around how to do data platforms and data warehousing in the cloud have been developed by smaller and faster moving organizations. And I'm curious what you have seen as the overall impact of the cloud and some of that early adoption on the overall practice of data modeling and the data architectures that manifest in cloud environments as compared to some of the on-prem environments that these larger organizations are still managing.
Yeah, absolutely. So, and I mean, you said it right. So, smaller companies moved to the cloud much quicker, obviously, because they didn't perceive the risk or anything. Like they didn't have that much to begin with. And they're getting started. They don't have large volumes of data, so they just quickly took advantage of the cloud platforms compared to larger firms where there's so many legacy systems running, and security was a big thing. When cloud started, every CTO, every executive was questioning the security, like how secure is it going to be once you put it on the cloud. So that was a big thing. So that took a while for a lot of companies to even kind of think about how to address that. As far as the data modeling goes, I think when these small companies or smaller environments move to cloud, things were most companies like startups, which move pretty quickly, and data modeling was seen as a somewhat of a hurdle, or in some cases they may not even aware of data modeling because they haven't done that in the past, so they may not know that was an important piece. So for that reason, it just went on, and people started building this really fast, and the data modeling took the backseat. And it's just for the last few years, it's just disappeared from the analytics space. It's coming back now, but that's what happened as these things move to cloud.
And in particular, with the data warehousing, data modeling approach of in particular dimensional modeling that was developed in the 90s in the era of these large and expensive data warehouse appliances that were typically resource constrained. There were a lot of conflicting priorities around what you needed to be able to answer and when. I'm wondering how you have seen the ongoing conversation around the relative merits of dimensional modeling versus some of the newer paradigms of wide tables, et cetera, and how that manifests and what the actual requirements are around modeling priorities in cloud data warehouse environments.
Yeah. So if you take the data modeling practice, I mean, we should probably look at why people used to model in the first place. Like, what were the benefits that people were getting out of modeling, right? I mean, there were three stages of modeling, generally speaking. A lot of people agree with this: the conceptual modeling, the logical modeling, and the physical modeling, right? So the conceptual modeling is primarily where you're saying, hey, I need to understand how the business or what the business needs. So what is that they want? What are the requirements? So in a conceptual model, you start putting all the entities, the business entities, and you start drawing lines between these entities to show relationships between them. And then you use this conceptual modeling as a way to gather requirements, as a communication tool to work with the business. It's much easier when you show something visually. You can sit in a room, talk to the business people, and say, "Hey, is this what you're thinking? Is this how the relationships are?" That's a thinking exercise. That's very important for the business and the people who are building the solutions to get on the same page. And then as you move towards to the logical model, it's more like the solution. You're talking about, okay, this is how I'm going to do it. It's still abstracted away from the physical implementation, but it's still a way to kind of draw out the solution. And then finally, the physical model. Physical models are where now they're closer and they could be different depending on the target platform. So if it's a cloud platform, you may have some decisions that you would not have done when you were doing an on-prem database platform. So as you get to the physical aspect of this, it's coming closer to the target platforms. So because cloud platforms do perform well, you can make some decisions like, hey, I don't care about the storage. I think the system can handle the compute, so this is fine. So you're basically kind of doing those kind of decisions as you move towards this. Now, coming to the dimensional models. Now, dimensional models are the same. I mean, dimensional models are for analytics mostly, and they are kind of report or analytics oriented models. Makes it much, much easier for the business to understand a model without getting overwhelmed with something like an operational model. Like if you have an operational data model, there's a lot of tables, a lot of relationships, and just becomes very, very hard to even write queries. But whereas if you show a dimensional model and if you do it right, it becomes much, much easier for not only kind of start with requirements and understand, but also once you do it, then business consumption, when they look at this, they can kind of relatively easily understand these type of models.
And as far as that dimensional modeling practice, just to expand that a bit more for folks who aren't familiar, this largely refers to the star and snowflake schema versus the data vault schema approach of the way that you structure the different tables and relationships within the warehouse, as opposed to what's typically third normal form in transactional databases. And as far as that actual exercise of defining these dimensional models and figuring out what are the actual attributes and dimensions, that can be a very complex and time consuming process. I'm wondering what are some of the ways that teams have worked through that to be able to manage the very rapid pace of requirements and the changing requirements with the upfront investment needed to be able to actually build out those models and cement them, and some of the ways that teams should be thinking about that balance of I need to get some answers right now versus this is going to help me in the long run.
Yeah, that's a very good point, and that's the challenge, right? So people fall in these traps, and one trap is, hey, don't do modeling because I can do it fast. or do modeling and perfect the model so I'll get it right. Both are wrong, in my opinion, because you got to get the right balance. If you skip the modeling exercise, regardless of whether we are doing it on cloud or not, then you're not taking the time to think. You're not taking the time to build that foundation correctly. As opposed to saying, okay, I'm going to spend all my time in modeling, then you're ignoring the business. You need to do, your end goal is to provide high quality data that can be expanded upon more requirements. As you get more requirements, you need to have a way to scale this. To do that, you need to balance. What I have done in the past is, my goal was to always kind of take the data, and regardless of, you don't have to model everything. You understand, you do that first iteration of just get a feel for it, do that conceptual model or logical model, whatever that is. Don't try to perfect that. Just get the first iteration of it, build something. It doesn't have to be purely dimensional model yet. It could be just views. And then put it out there as soon as possible. And then let the business and set the expectation that, hey, this is the first iteration. I want you to take a look at the data first and tell me, I have these questions, and do you see anything wrong? And then they'll look at the data. It could be just dashboards or whatever way that you want to, give them the data. It could be our Excel. They can download into that. But they can look at the data quickly and then give that feedback. Then you start thinking about, oh, now I understand the relationships. Now I can kind of improve my model and say, hey, this is how this needs to be. And then kind of follow those iterations as you go through. It will never be perfect, and that's okay, because everything is changing. Even though it may seem perfect today, it's not going to be as soon as the company goes and buys another company. Everything is like, the rules are changed now, everything is changed. So that's okay. But understanding that balance is important, and that as long as you're trying to improve it continuously, you'll be successful.
Another outgrowth of the cloud and cloud warehouses and the decreasing storage costs and the decoupling of compute and storage is the shift in the integration path from ETL, which was very uh, upfront investment. You had to make sure that you got things right, because otherwise you're going to lose information, or you're going to have the wrong assumptions and do the transformations wrong, and you had no way of going back and doing it right afterwards. Or if you did, it required a lot of extra engineering to give you that fallback, versus the ELT paradigm that has become prevalent of just load all of the data and then transform it, so that you don't have to think about modeling up front, which I think has had this downstream impact of saying, well, if I don't have to do all the modeling on load, well, I don't really have to do any modeling at all, because if I do it wrong, I can just rewrite it and rebuild everything and it's fine. And I'm curious what you have seen as the relative merits of the upfront investment requirements of ETL versus the very fast moving iterative capability of ELT, and some of the ways that that influences the overall thinking and patterns within a team or an organization as far as that data modeling, data integration, data analytics workflow.
Yeah, absolutely. So, ELT definitely has changed the game in terms of how you build these things. In the old days, when you had ETL systems, they became the bottleneck. They are very rigid tools, the GUI tools mostly, but they brought the efficiencies, but also rigid in terms of, you didn't, when you hit a corner case, you didn't have much control on it, and also you were not leveraging the investment that you made in the target platforms, right? The database platforms. But ELT paradigm has changed that. Now you have this full power that you can utilize on the using the database platform to do the transformations. So what that means is, yeah, you can iterate through much rapidly as opposed to the ETL paradigm. So yeah, as I said before, I think it's much more easier to do those kind of iterations, doing ELT on a platform like, for example, Snowflake or some kind of cloud platforms.
Another aspect of this question of data modeling, particularly with dimensional models, where it does make the understandability and discoverability of the core domain objects clearer, than if you have these one-off models that answer a specific question. But if you want to do any further exploration, then you have to go back to from the source and build back up to it. Is this question of data self-service for people in the organization, people in the business suite who don't necessarily have the capacity or time to dig deep into the data and understand it semantically. And I'm curious what you have seen for the teams who fall into that pit of, I just need to build this one model to answer this one specific question, versus investing in that upfront data modeling or dimensional modeling. Who is driving the actual effort of doing the analysis, and how does that manifest in terms of the ways that the teams think about what their priorities are of doing the upfront modeling versus just answer questions really quick?
Classic challenge, right? I mean, the business units are saying, I know my data, I understand my data. Even if you give me a model, I'm going to look at this model for this particular process, and I'm going to just build it for this one, and I'm happy. But the problem with that is there's not just one business process in a company, there's multiple business processes, and these business processes share a lot of data. So you have to have a way to kind of plan this from that higher level, like to understand, hey, what are my business processes? What is the shared data? What become dimensions? What become facts? And how are these dimensions linked? This is all very, very important to make sure that you're not building silos. Because just because you build a dimensional model doesn't mean that you're doing it right. You need to make sure that you are building with the intention to share data across these business processes and understand those. And there's a term Kimball mentions, called conformed dimensions. That was the idea. Now, we don't want to get into how we do that and what are the pros and cons and all of that. But generally speaking, the idea is, hey, there's a shared data set. You build that data set for one process, for one unit, and then make sure that you leverage and use that same thing to connect other data sets. So that way you kind of building this integration.
And as far as the overall ecosystem of data modeling practices, obviously Star and Snowflake Schema and Data Vault have been around possibly the longest, or they've been the longest lived. But I'm wondering if there are any other patterns or data modeling approaches that have been developed in recent years that you have found to be useful or beneficial, or things that are maybe built off of some of the Star and Snowflake or Data Vault approaches that make it easier to iterate into those dimensional approaches?
Yeah. So, I mean, to be honest, I haven't seen anything big like that. When dimensional models came out, when Data Vault came out, of course, there was the enterprise data model from Inman. So these were the major kind of data modeling methodologies. Yeah, as far as, I mean, there's time series modeling, there's like all these subsets of modeling that you can talk about, but nothing major in terms of revamping the whole thing. So if you're talking about data warehouses, you have a few options. You're saying, okay, I want to build my, use Data Vault. If you're seeing that there's a need to build a data vault for your business, then that would be a good approach to build that raw data, organize that, and then on top of that, you build your star schemas. So you're still building the dimensional models, but you're building on top of the raw data vault models. And there are situations where you may say, we don't do data vault. We can just go straight into dimensional models. There's pros and cons of each one of those. But on top of this, there are things that you can do custom kind of modeling, I would say. You can create aggregate tables if you think there is a performance thing and your data is like huge and you want to aggregate it, but make sure you aggregate it after you bring the granular data into your data warehouse, right? Because if you capture the data from the operational systems and you aggregate it right away, then if somebody's asking a deeper question to, hey, show me how you got this aggregated number, then you don't have a way to drill into it, because now you have to go to the operational system, which is probably already updated. So yeah, I think there's not I have not seen like a big model methodology since these two.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their extensive library of integrations enable you to automatically send data to hundreds of downstream tools. Sign up for free today at dataengineeringpodcast.com/rudderstack. Another element of the conversation today is the question of column awareness in the space of data modeling and data transformation. And I'm curious if you can just start by describing what you mean by that term and some of the ways that that will impact the approach of data modeling or the ways that data transformations and table structures are built up.
Yeah. So if you look at the data, I think columns are like the building blocks, pretty much. That's the lowest grain that you can go to in a data set, right? I mean, if you look at an Excel sheet, each cell is is the data value in a particular column. When we say column aware, it's basically column metadata. That's what we're talking about here. But how we can leverage that, that's the distinction here. How we can use it to its maximum potential to do automation is what we are talking about. By storing the column metadata or being column aware and using that, leveraging that from the ground up to do, whether it's modeling, whether you're generating code, whether you're doing column lineage, whether you're doing impact analysis, whether you're determining the state of your target database platform, you get all of those benefits just by leveraging that column awareness. And again, that's what we did at Coalesce. So if you look at anything that you're sharing with the business, whether it's a KPI or a metric, a KPI is made out of metrics. Like KPI is a key performance indicator, it's made out of metrics. And if a metric is usually made out of one or more columns, and these columns are coming from tables. So it always comes down to columns. You're applying transformations on columns. You're adding new columns. You're deleting other columns. You're working with columns. Data quality is about columns. So it just becomes so crucial to understand the relationships and the dependencies between these columns. And of course, columns in tables. Tables are just a collection of columns, right? So what we think is that that's the best way to kind of build an analytics system so you can scale. Because when you're small, it doesn't matter as much. When you're building a small system or a small database, small model, it doesn't matter much because you were thinking, I can write a query, I can get this done pretty fast. Fine. But usually that's not the intention. Like whenever you're working for a business, you're building, it may be small at that time, but the whole intention is to grow. They'll go and get more data sets, you're selling more, you're acquiring other companies, whatever but you have to have a way to scale. So that's where this comes into play. The automation comes into play. And to do proper automation, you need to be column aware.
So many different things to dig into there. So from the perspective of a table is just a collection of columns and the columns are the thing that you actually care about, I'm wondering if you can talk to some of the more nuanced aspects of that where, yes, a table is a collection of columns, but the columns within a table typically all relate to each other in some fashion. So there is some contextual awareness that you need to have to be able to operate properly on that column. And I'm wondering, what are some of the pitfalls that somebody might fall into if they say, I only really care about the columns, so this is the thing I'm going to track? What are the pieces of metadata that they might drop on the floor by the fact that they are maybe ignoring some of the other contextual and semantic aspects of the table that column is contained within, and the ways that column is propagated to other differently named tables or collections of columns, etc.?
Very good question. So when I say columns, a table is a collection of columns, it's true. However, there are dependencies, there are relationships between those columns. There's a primary key, there's a foreign key, there's all these other relationships that are very, very important. And that's where I guess the modeling comes into play. But there is additional metadata we store on these columns. It's about not just the name and the data type, but there is you can attach or you can tag things as foreign keys, as business keys, as change type 2 columns in a dimension. By doing those, now we can kind of leverage those additional metadata tags to do even more automation. We can generate scripts that would say, hey, if I know the business key, if I know the change tracking column, if I know the foreign key, I can just write this code or generate this code automatically. Same thing with data quality rules. I mean, I can take a domain like a financial domain, and I can tag these columns as certain attributes, like for example, a QSIP in a financial world, which stands for a stock. You can do those things and apply automation on data quality rules. So it's not just the columns, but also taking into consideration those relationships with the columns. What is this column do in a particular table? Is it the business key? Is it a composite key? More than one column, right? So all those are very, very important. I want to make sure that people, when they do modeling, that those are some of the key things that you need to start considering.
And for people who are building their transformations, they're doing their modeling, what are some of the elements of a given tool or workflow that are necessary for column awareness to be an effective component of that overall effort? So, what are the capabilities in a tool that need to be present for it to be column aware? What are some of the ways that that column awareness will be incorporated into the transformation and workflow of saying, okay, I've got this information in this column. I need to combine it with this column from this other table to merge it into this new attribute or this new metric that is then being propagated into this new table, which is a collection of columns, and some of the ways that lineage at the column level needs to be present to inform the transformations and the modeling efforts, etc.
Yeah, so being column aware, as I said before, it's not just storing column metadata or not just creating a lineage diagram. Those are the byproducts of being column aware. We have to leverage it from the ground up on everything that you do in the tool. So whether you're generating code or you're generating impact analysis or you're generating lineage, or even when you're modeling, you're selecting business keys, you're drawing foreign key relationships, you're applying data quality rules. So all of these should be part of the tool in a way that you can easily interact with the metadata and kind of enhance and enrich the metadata. So you have these columns, and now as a user, you understand what these columns are and what they are supposed to do, and what their function is and what do they mean. So you can enrich that repository, that metadata repository, by adding additional metadata. And as you do that, and how the tool would take that column metadata plus the enriched metadata that the user input and generate these other artifacts that I was talking about, like scripts or models or lineage diagrams or and so on.
And so, from that, another question is how much of the column awareness is intended for the actual consumer of the tool, of somebody who's building the transformations, versus the column awareness being a function of the tool itself and is something that is used to drive that automation without the need for as much direct human involvement?
Yeah, very good question. So we don't want to burden the user by making them understand or having them forcing them to use the tool in a certain way because we are column aware. It should be an easy to use tool. Whether you're a GUI person or you're writing some code, some template, it should be very easy to use, and you don't have to think about the column awareness. It's just given. But behind the scenes, because we are column aware, we can do a lot of automation for you. So it's mostly how the tool functions, but there is some things that kind of manifest into the UI. For example, because we know every column, we can show you a list of columns that you can select which columns are business keys. So that just becomes easy for you because we are column aware, we can show, hey, here are the columns, pick the business key, one or two, it could be a composite key, and also pick what columns are type 2 columns, for example. And the user can just kind of just go and pick rather than remembering and typing and putting it in a YAML file or whatever. So it's a combination, but mostly it's a function of the tool behind the scenes.
In terms of the overall tooling ecosystem, the default mode for a while at least has been to operate on the table level or even just on the task level where there is potentially no awareness at all of whether or not there are tables or columns or files being manipulated. And as we have gone through successive generations of transformation tools underlying compute platforms, we have gotten to a more granular and nuanced level of the tools having awareness of what are the underlying objects or resources that are being operated on. And I'm wondering, what are some of the complexities of managing this column awareness that have taken so long for us to get to where maybe the table was the previous level of understanding within the tooling, and some of the ways that that poses complexity in the tool development to be able to expose these capabilities and this semantic understanding of what is being done.
So we extract this metadata as upon discovery, right? I mean, as soon as you connect to something, we try to kind of extract this metadata and save that metadata, and then you're basing off of that metadata. You're going to use that as a starting point and build additional objects and additional workflows. As far as there could be down the road, there could be things where we may not be able to extract this metadata out of some, I don't know, like a video message. Maybe we don't need to, or maybe it's possible because the AI is coming on, and I don't want to go take this discussion in that direction, but I'm just saying things are changing. We understand, but regardless, the importance of having this column level awareness, it's not going to go away. But whatever in the near future, I can't see where we say, hey, it's too complex, so let's not do column level, just go back to the table level, or it's just like summarizing the data. Once you summarize, you lose the granularity. That's exactly what would happen. Is it difficult for the tools to build this? I think we should do as much as we can as vendors to do this. One key thing, though, what I've seen in the how this was done in the past versus how we're doing now is column metadata was an afterthought. Lineage diagrams were an afterthought. They were like, okay, after you do everything, whatever you're doing, then we're going to run something and scan it and do this. Well, that's not how we think it should be done. We think the column awareness should be the building block for everything. It should be the starting point for everything. And that's the fundamental difference. Yeah, it's challenging problem, but we have taken upon ourselves to solve this.
Yeah, that was another aspect that I wanted to discuss, is this question of column awareness and lineage tracking within the transformation tool and within the workflow of actually manipulating the data versus bolting it on or discovering it after the fact with some of these metadata platforms and the lineage analysis from the SQL logs in the data warehouse, and some of the ways that pushing that information into the transformation and data manipulation layer impacts the effectiveness and utility of these metadata platforms, whether it serves as a means of improving them or just serves as a means of obviating them entirely.
So you're basically asking if the way that the current tools, like after you build something, the way they extract those, is that useful?
Yeah, so basically, given the fact that metadata platforms have become popular because of the need for being able to expose this lineage information, et cetera, does having that lineage information and column level awareness within the transformation tool serve to improve those metadata platforms, or does it serve to help make them obsolete?
Yeah, I think it's the former. So it's going to help improve, or the metadata, yeah, definitely improve, because the reason for that is, I think when you do it as an exercise at the end of using a metadata tool to extract everything, they do a pretty solid job, but however, they won't be 100%. They're going to have some accuracy issues. But when you do it from the ground up like us, because we are using this as a basis to generate the code, so our lineage is going to be, for example, just since we're talking about lineage, there's more than just the lineage. I want to make sure that the column awareness is not, lineage is just a byproduct. But to answer your question, we would actually improve the metadata extraction that happens with these tools. So it's going to be more accurate. And another point here is, it also, of course, the whole point of this thing is it improves the productivity of building this in the first place. and the metadata tools would get more accurate metadata.
Yeah, it's interesting too because of the recent efforts of some of the metadata platforms to use their contextual awareness to feed back into the transformation process, some of the data platform automation. So, figuring out when do you want to schedule your different transformations to happen so that more of them can happen within a given time frame for cost management, et cetera. So, definitely interesting to see how that plays out. Another avenue that I like to explore in this space of column awareness in the transformation layer is some of the ways that that manifests outside of the context of the data warehouse, where within the warehouse it's very clear what the benefits are because everything has happened within that bounded context of everything is a column and it gets moved into another column. And so there is this similarity in terms of the operations being performed. But as you start to leave the context of the warehouse into something like a machine learning workflow or a streaming system, or as the data leaves the warehouse and feeds back into maybe a SaaS platform through things such as reverse ETL, how does the column awareness help in those external contexts?
Yeah, so I don't have a particular use case in mind, but I'm pretty sure that just like how we are saying we are going to improve the metadata extraction process to improve the accuracy, the same thing can be applied to other outside processes. Because we have this level of information and the quality of output that we are giving, that basically helps improve any external process that depends on this. Whether it's reverse ETL or some visualization tools pulling data, it's all connected, interconnected. I just don't have any use case on top of my mind, but definitely I see that it can only benefit these systems.
And in terms of your work at Coalesce and helping to think through the ways that column awareness manifests within your tool, and just as a general practice of column awareness being this core capability of the transformation layer, what are some of the most interesting or innovative or unexpected ways that you have seen that used either in the context of data modeling or the overall impact that it has had on the engineering workflow to be able to build out these different analytical data sets?
Yeah, so I mean, when we came up with this, and our clients started using our product, what I've seen is they started building these, what we call nodes in the platform. So a node is just a pattern, basically. A node type is a pattern, and behind the pattern you can write a template, and the template is actually leveraging the metadata behind the scenes, this column level metadata. So what I'm super excited is about these customers coming up with innovative templates. They are coming up with their own ideas of how they can leverage this column level metadata and start creating templates to meet their needs. So every time you write a new template, you're basically creating a new node type that can be leveraged by anybody. If they share it in the future with other clients, I don't have to rebuild anything. I just use the node type. But the way that they're doing is very exciting. How they're able to come up with innovative solutions to meet their needs, writing these node types.
And in your own work of building Coalesce and building this column aware tooling, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
It was definitely a journey for us. We have went back and forth on a lot of deep technical architectural things. What I have learned, let's see. I think the number one thing is the potential. I did not realize how much we can do with this, but the more we do it, the more we think we can do with this. For example, when we came out with it, we had some things in mind. Okay, yeah, we'll get lineage. Yeah, we'll get lineage. Lineage is going to be a great thing. But then we're saying, okay, not only that, we can start building this, what we call custom node types. That's another thing. But now we're saying how we can apply data quality, for example, with the same column level metadata. And now we're entering this AI world, and I can already see how we can even do some of those automation using AI with the column level metadata. So my point is, as we do more, we see that this architecture that we chose is still has a lot of potential to be used in the future use cases.
And for people who are building out their data transformation workflows, they're deciding on how best to approach their modeling, what are some of the cases where a column aware approach is the wrong choice?
I think there's no such thing, in my opinion, as column awareness is incorrect, because especially we're not asking them to spend a lot of time to do this. Now, of course, if you have a tool that is column aware, they don't have to do it. But if they have to build something, then from the ground up in their environment, and they have to make it column aware, then it's a different story, because then there might be situations where you might say, I don't need the column awareness for this. Yeah, it's possible that I can see some use cases where uh, they might, it might be an overkill for them. But if you adopt a tool that already has it, then then it's not a big deal, because you're only leveraging it. You're not trying to build everything from the ground up.
And for teams who are looking to improve their data modeling approaches, they're looking to simplify their overall workflow, what are some of the resources that you recommend that they look to for being able to learn more about some of the data modeling principles, some of the ways that column awareness can be added to or integrated into their overall workflow or tool chains, et cetera?
Yeah, I've been in this space for a long time, so my recommendations would be, the classic books, the Data Warehouse Toolkit from Ralph Kimball, and things like that. I don't expect everybody to just go through the whole Ralph Kimball book, which might be, first of all, a very lengthy book, and some people might feel like some of the concepts are outdated. But I think, as I said before, just focus on like the 101 of modeling first. Start there. I can't name one resource. You can find so much on the internet. But make sure that you understand what's the benefit of modeling? Why do we need to model? And don't fall into the trap of perfecting the model. That's another thing. My advice: always keep iterating, because it's going to change regardless. There is no perfect model. And I would say, there's a lot of resources, but start small and kind of play with them.
All right. Are there any other aspects of the overall space of data modeling and data architecture in the context of cloud warehousing in particular, and the capabilities and impact of column aware tooling that we didn't discuss yet that you'd like to cover before we close out the show?
One thing that I didn't talk about with the column awareness is the documentation that you get out of this. I mean, the governance aspect. I mean, you we have seen a lot of times where people take pride in coding, and which is great, and you code all these things, and as your environments get bigger and bigger, you have a lot more code, and then the person leaves, and then there you go. It becomes very, very difficult for anybody to kind of go and understand the code. And this is a classic thing. We all know this. But column awareness, again, another byproduct of that is the documentation that you can generate out of this. Now, how this was built. And you can also add context to also show why this was built the way it was built. And by just pushing a button, it can read this column metadata and generate this documentation for you. And it's always going to be accurate, whether you agree or not with that. But that's the truth. This is how it was built, and this is what we're showing. So that's another big value that you get from that.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think a tool or a platform, I would say. We like to call ourselves a platform because we think big, and where business and IT, power business users and IT architects, data architects, data engineers, where they can all work together on one single platform to build their data foundation and data assets. And that's the gap right now. Either the tools are too extreme to the business needs, so the business users are just using those tools, or it's the other way around, like the IT oriented tools that business doesn't have any visibility or or have the training to understand how these tools work. What Coalesce, for example, does is to bring these two types of personas or many other personas into the same platform. So everything is being built there and it's all governed in one place.
All right. Well, thank you very much for taking the time today to join me and share your thoughts on the benefits and challenges of data modeling and some of the ways that column-aware tooling can help with that overall effort. Definitely appreciate the time and energy that you and your team are putting into making that available. So thank you for that. I hope you enjoy the rest of your day.
Thanks, Tobias. Thanks for having me.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.